Next, moving on, we're talking about what's called Ohm's Law. Ohm's Law is the main law we're going to use when it comes to understanding electrical current and circuits, discovered by scientist named George Simon Ohm. Ohm's Law is very simple. It simply states that I equals V divided by R. Or, we're going to rearrange it later, V equals IR, or R equals V over I. So simply stated, the current flowing in a circuit is directly proportional to the voltage impressed across that circuit and inversely proportional to the resistance. So in other words, if you break this down, resistance is proportional to the ratio of electric potential divided by the current. So another way to think about this is resistance is opposition to the flow of charge. So if you look at the units here, you would need, in this case, 1 volt of electric potential to cause 1 amp to flow through a resistor that is 1 ohm, in honor of George Simon Ohm. We named resistance after him. And the symbol for ohms is this thing that looks like a horseshoe. It's the Greek letter omega. So in honor of George Simon Ohm, we use omega to represent resistance here. And in terms of Ohm's law, this form is the most conceptually easier one to understand. That if you want more current to flow through a circuit, you need more volts. And if you want more current to flow, you don't want too much resistance. So for example, if you have a cordless drill and you want more current to flow, so it's more powerful, then you want a bigger battery pack. So instead of a, cheap 12 volt cordless drill, you can get a 24 volt DeWalt cordless drill. And then maybe another example is if you want to turn on your lights in your family room and you want it to be really bright, you want a lot of current to flow, then a lot of times you have a light dimmer switch. So if you have very little resistance, you're going to have more current flowing. If you have more resistance, you'll have less current flowing. So kind of like you turn on and off a water faucet, light dimmer, same idea, you're changing that resistance. It's usually what's called a potentiometer or a variable resistor. Next, we want to talk about what are called ohmic conductors. Big fancy word. An ohmic conductor is just something that obeys Ohm's law. That's all it is. So in this case, we have a graph of current versus voltage. And an ohmic conductor is a straight line. It's a linear relationship, directly proportional. In this case, it's obeying Ohm's law because if you have, let's say, twice the voltage, you're going to have twice the current flowing through there. If you have 3 times, you're going to have 3 times the current, etc. And usually resistors, these are pictures of resistors with these color bands. They're made out of a ceramic material designed to precisely obey Ohm's law so we can exactly predict how much resistance we're putting in or taking out of a circuit. Now in real life, most things are non-ohmic conductors. They don't obey Ohm's law. So for example, a classic light bulb. A light bulb works by heating up a filament, which is a metal that's designed to get really hot. Usually we use something like tungsten because it's durable, it can get hot and then give off light. And so if you graph out the I versus V graph, current versus voltage graph, it's not a straight line at all. It curves. Okay, as it gets hotter, you actually get more resistance, so you get less current flowing. As the temperature changes, it changes how it responds. So you can't predict exactly what's going to happen. It is non-ohmic. Next, a little secret triangle when it comes to Ohm's law. This is just a simple algebra trick. So the trick is draw a little triangle and put V on top, I on the left, R on the right. And so what's cool about this little secret triangle is we can come up with all 3 forms of Ohm's law. So let's say we want to find first the equation for V. So the trick is, all you got to do is cover up this V with your hand there. So notice we have I times R on the bottom. So V is just simply I times R. Let's say next we want to find I. So how can we get the equation for I? So all we got to do is cover up I with our hand. And notice on the triangle we get V over R. So I is equal to V over R. Finally, let's say we want to find now resistance. That's all that's left. So again, we're going to cover up R with our hand, and we got V over I. So R equals V over I. So the little secret triangle, it's really not a secret, but it's just a nice little algebra trick